We've been doing a survey for high magnetic fields in this house by turning on all the lights in the house and looking for areas of elevated magnetic fields. And we've discovered one in the hallway which accesses the bedrooms. Here's our meter. We turn it on and you will be able to hear what we found when we were doing the survey, which is to say a elevated magnetic field and a much faster clicking rate on the meter. So if we turn the light off for the meter, then the magnetic field meter is dropping off to a much lower level than it was. It's actually showing 0.3 milligauss. And that's kind of contrasted to a little bit earlier, it was 0.6 milligauss. And that is because of the distribution wiring issues that we were discussing when we were out in front of the house looking at the transformer and the places that the power comes into the house. So we can do this again. If we turn the light on, the fields go up and we move our way down the hallway, and that continues to suffuse the entire hall as we go along. So these types of wiring errors where we have unequal current flow on one of the wires or several of the cables can result in fields affecting larger areas of the house than you might expect. What can you do about it? Well, you could get rid of one of the switches and just have a switch in one location. It would be down at this end of the hall. There also are RF versions of these switches where you do the switching signal is going through the air and turning on and off this switch from that switch by an RF signal, and that would also solve the problem. And probably the more costly is to break a hole in the wall and replace this cable with the 3-wire cable. So we have another meter here which you may be interested in, which is called the Dr. Gauss. It's a low-cost single-axis meter with an interesting ability to make noise. And we notice that we have a very loud noise when this light is on, and we turn it off, it goes away. So it makes a handy way to demonstrate to your clients that these things have reality to them that wouldn't involve looking at the meter, but you can see from the meter here that the needle goes up. You also notice that as we turn the meter sideways, the needle goes down and the sound goes away. That's because this is a single-axis meter, and magnetic fields have directionality. They can be back and forth, up and down, and in and out, or any combination of those. And when we turn it to the right interception direction, then you get the maximum reading on here, which is about 7/10 of a milligauss, as well as the maximum noise. So it's a handy little device that you can get for, it's around $35 plus, shipping. We were inside the house a few minutes ago and had turned off all of the power to the house, and we were still, measuring a significant magnetic field all over the house under the condition of no power to the house. And so that suggests there's an issue outside. So we look outside the house and we found a transformer, which is probably powering every one of the buildings we see all the way around us here. And in fact, the building that we came out of is the one over to my right. And we've used this buzzing stick, if you will. You can hear it buzzing. We've used that to identify where the wire is coming through here. So we get down above the wire and you can hear there is a higher field here, and we drop the meter down and we have like a 2 milligauss, nearly 2 milligauss field coming from the wire that's in the ground. And this 2 milligauss field is basically going all the way down through between these two buildings and working its way to the power panel and meter, which is supplying this house and an additional 2 units further on. And the effect of this is that the field from this wire, which is a condition of unbalanced current flow, is affecting the majority of the house. So if we also bring our attention around over here, we know that this transformer has to be supplied with power from someplace, and that power is coming along here and going out into this parking area here. So we have a situation where we have a V in front of this house, which encompasses the entire width of the house and has this net current condition and is affecting what's happening in the house and giving highly variable fields. When we arrived here, the field was 2.3 milligauss pretty much throughout the house. It's now around 0.8 milligauss, and it's jumped up and down during the time we've been here based on the loads that are going on in these houses. Somebody has a washer, and the washer starts up and draws a very large current, and then we see a spike in magnetic field in the house here. Once that thing started up, then the fields go back down. And as people add loads in all of these houses, the current flow goes up, and we have greater magnetic fields coming from this distribution wiring in the ground, and it's affecting the house. There's really no easy solution to this, although this should not be happening in a balanced distribution system, and depending on the power company, they might be willing to work with you to resolve the issue.